Looking into our crystal ball, what do we see for AI? Every forward looking company will soon begin the journey of adopting and training its own private AI model. Getting this process right will separate winners from losers. But what does it all entail? Tune into this episode of Future Proof to hear experts explain what to do and what not to do as we spill the beans on the dirty little secrets of AI.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh here. Excited to enter 2024, our first show of the year, and DM Radio turns 16 years old next month. So apparently it's going to get a driver's permit. We'll be able to drive around and meet all of you. I'm joking, of course, but it's been a wild ride. And I have to say, I knew 16 years ago that data was going to be huge. It was going to be really important for the business world. And I am shocked at how big it's become. Of course, now AI is the hot topic. Gen AI, thanks to ChatGPT, Google's Bard, of course, Anthropic. There are multiple companies in this space now. AI is white hot, but guess what? You know what AI needs? Data. And in fact, clean, governed, trusted data is the cornerstone of good AI success. We'll talk about that a bit today. And of course, Gen AI is the hot topic. Interactive AI is what we're going to be talking about today. We'll talk about Gen AI in a few weeks. We may talk a bit about it today on this show. But I can tell you that AI in this new iteration and in this new phase is going to absolutely transform business applications, how business applications run, what they do. I think a lot of these AI models are going to subsume whole segments of traditional enterprise software. Low-hanging fruit, certainly chatbots. That's one thing interactive AI is good for. Also, things like HR, basic questions for HR, customer service, things of this nature. These technologies are great. But down the road a little bit, I look to this as a huge transformation in the analytics space. And I think the big vision in my mind is that every company, every big company at least, or every forward-thinking company is going to have their own model. They're probably going to pick their poison, either OpenAI through Microsoft or Google's Gemini or Anthropic with Claude. They're going to pick their poison and they're going to start training their model. Ideally, using a vector database is typically how you do these things, but you can actually embed it into the model itself. And they're going to build out their own models. Well, a couple of interesting things here before we bring our guests in, and we have two absolute rock star guests today. Sanjeev Mohan of SanjMo, former Gartner analyst, now on his own, doing tremendous work. And my good buddy Usama Fayyad, who has a cool new gig now. He is the inaugural executive director for the Institute for Experiential AI at Northeastern University. So we're going to talk about that and some of the secrets, the dirty little secrets, if you will, of making AI really work. Which, you know, the narrative, as I like to say, the narrative is always wrong. So the narrative in the media is that, oh, AI is going to take our jobs and it's bad. It's the red-eyed robot. And you can just flip it on and it's going to run your company. That is absolutely, positively not the case. AI really is going to require a lot of training, a lot of attention. But as I suggest, every big company is going to have their own model. They're going to work on that. And you got to be careful about training these models, you know, so you want embeddings of how you train them, anchors of truth, as someone called them. I love that concept. And you'll use this RAG model, which refers to retrieval augmented generation. And basically RAG, which came out of Facebook, is designed to ground or moor the content that comes out of a large language model. So you have to remember these large language models, they are predictive in nature. That's really all they are. They're systems of weightings. They've been trained on all this open text that's available on the interwebs. And their job is to predict what words you want based upon your prompts. So, you know, the old cliche, ask a stupid question, get a stupid answer. Well, load a stupid prompt, get a stupid return. Is what's going to happen with all that stuff. But be careful about training them. I often use this analogy of raising children. That's what you're doing with embeddings. All the significant memories you have in your life, whether at school or at work or other places, those are embeddings in your personal model, your real world AI-like model. So it's hard to untrain stuff. You got to be careful about that. So you don't want to get it off on the wrong foot. You want to get it off on the right foot. And that's going to be quality, trusted data, which means the data management stuff is really important, even more important than it was before. But with that fun opening, let me bring in Sanjeev Mohan of SanjMo. Sanjeev, these are crazy times we're in. I mean, this is a massive inflection point that is going to affect basically every corner of business. What are your thoughts about AI and where these things are going?
So I love how spontaneous this whole recording is, because I had no idea you would start with example of how a child learns, because what AI is really trying to do is seriously mimic how humans learn stuff, how children learn. And actually there's a lot of very interesting research and parallels between the human memory and LLMs. For example, in our brain, the back part of our brain is called the hippocampus. Hippocampus is actually there are a couple of other parts. Amygdala is another one. These these are the oldest parts of our human brain, and they store our long-term memories. They are like vector databases. The youngest part of human brain is the front. It's called the prefrontal cortex, and the prefrontal cortex is where reasoning takes place. So it takes the memory that we have and it reasons in front of our head in prefrontal cortex. That part is like an LLM. So why is it so important for humans to have a long, restful night of sleep? Is because all the experiences that we gather that get lodged into our hippocampus, the neural network then starts wiring them together. And so then next time we have a similar situation, we know how to react. And that happens by reasoning. Now, AI is not very good at reasoning at this point, but we are getting there. Other thing AI is not very good at is taking actions. So what is it good at? It's good at reading long documents. In fact, it's finding already a lot of adoption in contact centers, customer support, HR, because these departments have long documents. So if you can read those and you can start predicting the next token or the next word, then you can help the consumers. So I use AI all the time without even realizing. I've noticed how good Google Docs, email clients have become, where it's already predicting based on the preceding words, it's predicting what I should write next. And so summarizing, translation, all those things are already being done very well. Of course, there's hallucination and all that we'll talk about, but that is the state of AI. We are trying to mimic the way humans learn and copy that in the world of AI.
Yeah, and that was the whole point of neural networks way back when. I mean, I've been studying these things for quite a long time, but the amount of progress that's been made in the last few years really is staggering. And it's partly due to the transformer models. And Jürgen Schmidhuber, I've had a thread going with him back and forth. He wrote those papers, and what's funny is he wrote them like in the 1990s or something. So it goes to show you that it took a long time for the compute power and the architectures of computers to meet this demand. And of course, GPUs, and we'll talk a bit later about the CPUs, but it took a long time for us to get here. But now here we are, and it's obvious that this is going to shake the foundations of enterprise computing, right, Sanjeev?
Yeah, so thanks for bringing this up. I think the fact that technology advanced to a point where we could do some of these things now, they made it possible. In 1990s, there were great ideas. In fact, AI started in 1959, I believe, in some university but technology is definitely a big advantage we have today. The second thing is the transformer model you said. Prior to, in fact, even when I got into this space of data analytics and AI, we would take a model and then just completely retrain every bit of that model every single time. In 2017, Google came out with a paper called Attention is All You Need. And all of a sudden, this transformer model made things even more possible because now it's sort of in an iterative manner. Incrementally, we can train bits and pieces. So now we can go a lot faster. So not only do we have GPUs, but now we have a better technique of creating these foundation models. And that's why all of a sudden, we see, so in 2017 transformer model came out, then GPT-2, GPT-3 came out many years ago actually. But the moment we had chat GPT, we instantly gave a user interface in which anybody in the local language, mostly English, but I'm not sure about other languages, could ask a question. And that was literally the inflection point where AI became mainstream.
Yes.
So,
Without question. That's exactly right. And I remember when that happened and like, boom, it was like an explosion or something. And I do want to comment, I'll bring Osama in here in 1 second, but one of our regular listeners, a super smart guy who often sends me emails, Alex Husky, he works for XL or Exxon Mobil, I think it is. And he sent me this email that was really compelling. I used it in a webinar with Vertica a couple weeks ago. He said, we cannot allow these things to pattern recognize their way to the truth, which is very interesting because that's really what they're doing. It's pattern recognition. It's understanding this looks a lot like that, so I'm going to go ahead and put this forward. It's all pattern recognition, but there's no moorings, at least in the LLMs, right? That's why you have vector databases. That's why you train your models on trusted data, because you're giving it these anchors of truth, almost like you try to hold down a hot air balloon with the cords, right? You're trying to hold it down to earth and keep it focused on what's going on here. Not that you'll ever be able to completely eradicate the hallucinations. I don't know, but we're certainly gonna find out. But with that, let's bring in Usama Fayyad. What are your thoughts about all this stuff? And I Sanjeev and I seem to agree this is absolutely transformational. This is not just some evolutionary modification of how we do things. This is going to fundamentally change how we think about software. And frankly, I think these new models are really going to be almost like the new application fabric going forward. But what do you think?
Yeah, I think, well, I agree with some of what's been said. I have a few disagreements here. I mean, we'll start with, so first of all, I mean, you mentioned that it started a long time ago. It's even longer than what you implied, Sanjeev. This whole thing started with perceptrons, which is from the 1940s. Frank Rosenblatt kind of published his first algorithm in 58. In 1958, right after he published that article, there was a New York Times article talking about machines that teach themselves and how they're going to replace our jobs and all of that. So the hype has been around for a very, very, very long time. I think what has been changed recently is kind of, for sure, the compute and the ability to kind of spend huge amounts of money and energy on compute. Let's not forget GPT-3, which is the predecessor of 3.5 and 4.0. And that was the last time, back in 2000 was the last time OpenAI was open about what it was doing. Had 175 billion parameters in its large language model. The cost of training that on a very limited data set was about $3 million worth of energy just to do the training once. Now, that leads me to a few items I wanted to comment on. I think a lot of the technology today, from a scientific perspective, it's very simplistic. It's really just autocomplete on steroids. All of these models work by guessing the next, not even word, but the next token. So what's the next most likely token to autocomplete what typically starts with a prompt? And the prompt gives a way to restrict kind of those memories and say, hey, do your retrievals or your autocomplete based on what's in this prompt. And the prompts are very limited in size today just because of computational costs and so forth. So I said scientifically not very interesting, although there's a couple of interesting facts. One of them is, how could a model with so many parameters, and remember I said GPT-3 was 175 billion parameters, We think 3.5 is about $500 billion. We think GPT 4.0 is about 1.3 to 1.7 trillion. No one, I guess, outside OpenAI and maybe Microsoft knows. But regardless, trying to train, and I'll talk here about what Eric referred to as the secrets. I don't know if I call them dirty secrets. They're not, but they're not talked about a lot. The secrets of making AI work that the companies don't talk about a lot are, and I have a list of 7 of them, but I'll focus on the big 3. The big 3 are: 1, it's continuous need of human intervention and correction. So don't underestimate how much human intervention is happening, both in real time and on a continuous basis, to get these models trained up so that they work. And if you remove the human intervention, which, by the way, our term experiential AI refers to AI with the human in the loop, because we actually recognize how important it is to have the human intervention to correct the AI. And in generative AI, this is especially needed because all these models are knowledge free. All they can build is a whole bunch of weights or parameters and hope that the autocomplete works. They have no conceptual models. They have no understanding of what they say. The technical term for large language models is stochastic parrots. They are parrots in that they don't understand what they say, and stochastic in that they have a degree of randomness. So they appear to have variation. And we'll get back into kind of hallucinations, or what we prefer calling errors rather than hallucinations. But let me talk about so the first secret is huge amount of human intervention is needed. So after the training, for GPT-3, after the $3 million of energy usage is spent, that's not the end. You have to actually put an army of people against the model to do what's called fine-tuning or post-training tuning. And that's where they catch all the weird corner cases and so forth. Lots of reinforcement learning, lots of feedback coming from humans. And the reason you need humans is you actually need the common sense reasoning, which no machine today has. No AI has common sense reasoning. So you need the humans for that reason. So that's secret number 1. Secret number 2 has to do with data. So Eric very eloquently said, you need trusted data, well-managed data, truthful data, all of that. What the companies don't talk about is that data set that, say, GPT-3 got trained on. It is not the entire web, as many people try to tell you. In fact, they started with that path, and they quickly realized that doesn't work. The web is filled with contradictory information, bad data, hate speech, all sorts of weird stuff. So they had to go back and do a lot of manual curation. That manual curation is not cheap. This is why OpenAI needed all those billions of dollars of investment, both for the energy and compute infrastructure, as well as the curation of the data, which is a big, big deal, right?
Yeah, and let's pick this up after the break, folks. Don't touch that dial. We'll be right back. Usama, we cut off at the last segment there, and you were talking about how with ChatGPT, it was not, in fact, trained on just rando content all over the web. They figured out pretty early that's not going to work. We have to be careful about curating this, but go ahead and pick up where you left off.
Yeah, so the cost of curation is extremely expensive. They also went to sources like Wikipedia, which is moderated content. They then thought, hey, scientific articles, people are unlikely to lie or put false facts into scientific articles, so let's use that. So there's a lot of the use leveraging kind of the curation. That's the second secret, which is you gotta curate the data and you gotta very carefully put it together. The third one that is not talked much about, but I suspect will become talked about a lot, has to do with prompts, right? So people are talking about, New York Times had an article about prompt engineering, and people are talking about the new job of prompt engineering. As my colleague, who's a professor at Northeastern and a core member of our faculty at the Institute, Byron Wallace, likes to say, it's not really prompt engineering. It's all more like black magic and and weird casts here. The reason he says this is because a small variation in the prompt can give you a completely different result. And this is ignoring the errors and all of that, just changing that prompt a little bit. And people are writing papers now on how adding some weird prefixes to the prompts kind of restrains your attention and gets the LLM to produce a much better answer. And there's a lot of fun and interesting papers to read on this. So that's the third area, which is a huge dependence on prompts, and nobody understands how to do the prompts right. In fact, RAG is one of the attempts to kind of try to control and do some post-prompting to fix the issues by doing lookups. And the lookups are there because they're trying to overcome the bad reconstructions that the autocomplete comes up with, right? So certain tasks where you require a precise answer, like if you're trying to come up with a bibliography, or if you're referring to certain legal cases, you can't just do it from memory. You gotta be very precise. And if you try to do it on an autocomplete basis, you'll actually end up making up things like references and making up things like prior cases, which has happened with that famous lawyer who submitted a very good-looking and eloquent brief to the judge without actually checking the cases that were quoted, and ended up being sanctioned, and some say lost his license. But anyway, the point is that when you use these models, and this is why I don't believe these large language models are going to replace us, they need a lot of human processing after the fact to basically judge, edit, and adjust the output. And that is critical. This is what happens a lot inside the companies, a lot of adjustments and interventions. When it happens when you use it as a user, it often, that information doesn't get captured, and that's another lost opportunity, which might lead us to discuss private language models versus the public language models. But saying this, hopefully kind of can help demystify how we think about these models. I said scientifically they're not super interesting. There's a couple of interesting scientific facts about them. No one today scientifically understands why a model with so many parameters actually works. Statistics actually has theorems and wisdoms that basically say if you have too many parameters, you will overfit and never learn correctly. And overfitting is a huge problem in statistics. But it turns out as you increase the parameters beyond the zone of where you're overfitting and your performance is going down on the test sets, somehow nobody understands why. Around the millions to billions of parameters, the performance starts coming back. And no one has a scientific understanding of why. Statistics says that should never happen. So that is an interesting scientific fact. But I would say the one thing that's interesting, which is why these models will be with us for a long time to come, is that they hold a huge promise economically. They address many of the tasks in the knowledge economy today. And in the richer countries, the knowledge economy is about 50% of the economy. And in poorer economies, it's somewhere between 19 and 29%, according to the UN. But if you have something that affects half the economy, even a 2% or 1% acceleration can have a huge, profound impact economically. And this is because we created a bunch of jobs in the knowledge economy that are very robotic, very repetitive, very mundane. And that gives a window for a lot of these large language models to do their thing with their autocomplete capabilities and help us accelerate. Now, people are not talking about 1% and 2% acceleration. They're talking about 30 to 50 to 80% acceleration. And that's a whole other area that basically says whether these models are scientifically interesting or not, they are economically very interesting in the context of the knowledge economy.
Yeah, that's all excellent content, Usama. Thank you very much. And I'm going to bring Sanjeev back in, but you reminded me of a very interesting story I encountered. This is analogous in a certain sense. We tried to get to Europe last year for a conference, a very fun event sponsored by Software AG, and I wanted to bring my family, and we needed to get their passports. And post-COVID, going through the passport agency is just not fun at all, because typically in the old days, and it's still true, but if you had business travel and you could show that you have tickets and all this stuff, then you could get an expedited passport, but you have to go to one of the passport facilities. And it turns out they're all backlogged. Every last one of them is backlogged completely. And of course, this is the US government, so you can't expect the cutting edge in terms of system design. But I figured some things out. So you have to call in and try to get a meeting somewhere. And the closest one here is Buffalo, New York. And then there's DC and Baltimore and lots of other places you can go. And it was incredibly frustrating. You have to go through this whole litany of questions to answer. Do you have travel plans? Yes, I do. What's your city? Blah, blah, blah. Like, it's like 10 questions in a row they ask you. I got to the point, I made 100 phone calls, okay? I got to the point where I would just read off the list of everything they're going to ask me. And then one guy said, oh, I'm sorry, I still have to ask because those are the rules. I'm like, all right, fine, whatever. And every time you would get to it, you'd either be like, sorry, there are no appointments, or they would say, there's an appointment in Buffalo. I'm like, okay, great. And then they'd ask you all these other questions. And by the time you answer those questions, that one is gone. So the system doesn't have any sort of lock on it, meaning like once someone's in, someone else can take that from you. So I'm thinking, what is going on here? One young lady, very clever young lady, she says to me on the phone, she goes, let me just put in some random characters here. So basically, she tricked the database, this system. She just typed in rando characters instead of what you're supposed to do, which is give it cities and all this other stuff. And it worked like a charm. She goes, okay, do you want Seattle, San Francisco, or Vancouver, or whatever? It's like 3 different cities. I'm like, what? I'll take San Francisco or Seattle. That's what it was. Because, of course, Vancouver's in Canada. But so anyway, just to your point about one small change in the prompt can give a very different answer that has its origins in traditional queries, because you can sketch out a database with a weird query. And what was it? Mark Madsen once told me that it takes 10 years of a database in production before you're going to find the edge cases that will crash it. So we're still in the early days of understanding these things, and the more you play with them, the more you realize, and here's the last point I'll throw over to Sanjeev, these things have captured a tremendous amount of information. And while it's true that they will make stuff up and have these errors, there is an astonishing amount of detail, scientific detail, language detail, all kinds of things are buried in these systems somewhere. They're trained somewhere on they're persisted someplace. So it's going to take a while just to figure out what they already know, which is a ton. But Sanjeev, take it away.
Yeah, thank you so much, Eric. Great example. And just want to build upon what Usama said. The economic value of these new AI models is tremendous. In fact, I've seen they can raise GDP of a country by 7 to 20%. McKinsey has said every year it's like $4+ trillion will be added to the economy, global economy, every year, not just one. So so I trust, if not that much, at least there is a lot of value to be added.